So the other way that we can graph some of these linear equations is by using those x and y intercepts that we've talked about. And so I'm going to show you an example of how you find the x and y intercept and then give you guys one to try on your own. So when you're trying to find the x-intercept, remember that we had talked about the fact that when you have the x-intercept, your y is always going to be equal to 0. So what you can do is in the equation that we have up here, you can actually set y equal to 0. So you'd have that negative 2x, and instead of plus y, I'm just going to put 0 in for its place, and then equals 6. So what happened there is that my y coordinate was 0, and so now I'm just left with having to find the x. So this is becoming negative 2x, because plus 0 isn't going to change anything, equals 6. And then we divide both sides by negative 2, and we get x equals negative 3. And if you wanted to write that as a coordinate, you found x to be negative 3 when your y was equal to 0. So now a very similar process is done when you're trying to find the y-intercept. So remember, for the y-intercept, that is when your x is equal to 0. So just like I was able to replace my y with a 0, I can replace my x with a 0. So I'm going to write negative 2, and then I'm going to put 0 right next to that. And I put it in parentheses when I'm plugging in that x value. And then I have plus y equals 6. Now that negative 2 times 0 is going to 0 out, and I'm left with just y, and that's going to equal 6. So then I can write it as a coordinate. This time, no, your x was equal to 0, and you got 6 for your y. So these 2 points are what we can use to help us graph this new line using that x and y intercept. So if I go and look at the graph now, I can put one point at negative 3, 0, so that's on the x-axis, which means I would just go to the left 3 and draw a point. And the other one is at 0, 6, which means I would go up 6 on that y-axis to draw those 2 points. And like we talked about when we were graphing in like slope-intercept form, I said that you really only need 2 points in order for you to be able to graph the line. So you should be able to connect those 2 points and create your line. So I want you guys to take a look at this problem. Go ahead and pause the video and give this one a try by finding the x and y intercepts and then graphing it. And when you're ready to see the solution, go ahead and resume the video. So I'm doing the same process that I did for that other problem. For my x-intercept, I'm going to set y equal to 0. So that looked like 3x minus 0 equaled 9. And that became 3x equals 9. So x came out to be 3. So that would be 3, 0 as a coordinate. And then for the y-intercept, I'm going to set x equal to 0. Oops. And so I have 3 times 0 minus y equals 9. You should have been left with negative y equals 9. Make sure that you divided both sides by a negative 1, because we never want to have a letter be negative. So that came out to be negative 9 for the y. So then that would be 0, negative 9 for that coordinate. So then when you went to graph this one, you should have gone to the right 3, because it's 3, 0, and you should have went down 9 on the y-axis. So those are those 2 points, and then once again, connect those 2 points to get your straight line. Now the other way that we can graph equations is by using a table. Okay? And if you're using a table, you want to make sure that your equation is solved for y first. So you want to get your y variable by itself. So what we're going to do here is using this equation that they give us, I'm going to solve for y. Now, right now it says y minus 3, so I'm going to add 3 over to the other side and rewrite this. So now it's going to say y equals, and I'm going to keep it in that slope-intercept form that we talked about, which means that the x comes first, so the 2x comes first, and then we have plus 3. Now, when you go to create a table, what you're basically doing is you're putting in values for your x, and that could be any numbers. Now, I would suggest using some negatives and some positives. That way you kind of get a good range of points. But what you're doing is you're taking these individual numbers and you're replacing x with them. So you can see I did the first one. I picked -2. I plugged it into my equation. So I did 2 times, in parentheses, -2 plus 3. And when I do that math, that comes out to be -4 plus 3, which gives me -1. So this is 1 point that would be on that line, -2, -1. Now I can continue to find other points by putting in other values for x. For example, I could take 2 times -1 and then add 3 to it, and that would leave me with 1. So this next point would be -1, +1. And I could continue to fill out this chart by putting in a 0, 1, and a 2. And then just doing the math here. So this next one would become 0 plus 3, which is 3. This would be 2 plus 3, which is 5. And then we have 4 plus 3, which would be 7. So then again, we can write them as coordinates 0, 3, 1, 5, 2, 7. And once you get enough points, now what we can do is graph them and be able to see what our line looks like. And you should be able to see like a pattern with your points. So like if you're looking for the slope, you know, the slope is that 2. So from all these points, I'm going up 2 and right 1, just like we've done in the past. And there's your straight line. So then you go ahead and connect those points. Now on a problem like this where you've got a table that you're trying to fill out, they may be trying to relate this to like a real world problem. So they're going to have you look at this as if these numbers are actually representing something in the world or in your life. Okay, so for example, this one underneath we have some follow-up questions. It says, let's say that the x-axis up here represents hours. Okay, so this would be that axis. And the y-axis represents like feet of water in a pool. And they're asking, what does the above graph tell you? Well, since this is going up over time, if we look at the picture of our graph again, I could probably make a conclusion that the more hours I would be filling my pool with water, the more full it's going to get. If I keep that hose running for a long period of time, it's just going to keep pumping more water into my pool. So I should be able to make the conclusion that over time, the pool is getting more full. Now they may also ask you a question like this next one that says, how many feet of water would be in the pool after 4 hours? Well, 4 would be your x value, and so what you could do is go back to that equation that I had earlier when I was filling out my chart and actually put in 4 for x now. So we'd be taking 2 times 4 and then adding 3 to that, and that would come out to be 11 feet. So after 4 hours, I could expect there to be 11 feet of water in my pool if it was able to keep filling and filling and filling and never overflow. So I want you guys, again, to try to do this one. So there's 2 parts to this. They want you to create this table, and I'm going to suggest that you use some of those same points that I used on that other problem. So I would go -2 to +2. Remember that you're going to have to rewrite this equation first. So solve this equation for y to get yourself started. Then fill in your chart here, and then graph it, and then answer this follow-up question. So if you want to pause the video here to give yourself some time to work on that, and then come back, hit play when you're ready to see the solution. So the first thing I would have done is rewritten this equation, and we do that by subtracting 3x from both sides. That'll get my y alone. So this is going to say y equals negative 3x plus 1. So up here in my chart, I'm going to go ahead and put that equation in the middle. And then what I'm going to do is take all these points and start multiplying them, or like putting all those x values in and multiplying them to that negative 3. So I'm just going to fill out this chart. Okay, and so the numbers I've got were 7, 4, 1, negative 2, and negative 5. And remember, these are coordinates, so like all those x values match up with those y values. So now I'm going to graph. So negative 2, 1, 2, 3, 4, 5, 6, 7, way up there. Negative 1 is at 4. 0 is at 1. 1 is at negative 2. And 2 is at negative 5. So you should see a straight line again, though. This one, however, is going down over time. So this would have a negative slope, which we kind of saw that when we had that negative 3 in front of the x there. So this has the follow question saying, your graph represents the depth of a scuba diver after every second. What is his depth after 3 seconds? Well, if I were to just add one more row to my table there, I would be able to figure out what that is. But what I can do here is take this equation, negative 3x plus 1, put in 3 for x, so it's now negative 3 times 3 plus 1. So that would be negative 9 plus 1, which is going to come out to be negative 8. So I would expect him to be 8 feet, like under sea level, after 3 seconds.